So the intro to functions was all of 1.1. 1.2 is entirely about piecewise functions. So let's talk about what a piecewise function is. So it's a function that uses more than one formula to find the output, and each formula has its own domain. I think that that's kind of confusing, but I think most of you, if I show you this, know exactly what a piecewise function is. Yes? We've all seen these. This is a piecewise function. So it's saying, okay, for this part, this is the domain. For this part, this is the domain. For this part, this is the domain. It might be easier to think about it the other way around, though. If x is less than or equal to -1, where on a graph would that be? This chunk is defined by x squared. And then if it's between -1 and +1, we're talking about this chunk of the graph. That's defined by the square root of 1 minus x squared. And then if we're talking about where it's greater than 1, we're talking about this area over here, and that's where y equals x. Does that make sense? Okay. So that's what piecewise functions are. So let's go ahead and start with just working with piecewise functions. Let's go ahead and go down to the bottom of this page. So if it's asking for f of 0, where does 0 fall into this domain? Like, which chunk does 0 go in? This one, because 0 is between -1 and 1, right? So what we do then is we plug the 0 in, just like we did with a normal function, but this time we need to specifically plug it in to the 1 minus 0 squared. Okay. Well, what is 0 squared?
0.
What's 1 minus 0? What's the square root of 1? So f of 0 equals 1. Okay. I have a question for you. If x is 0, what do we call that value on a graph? X is 0. We have a point at 0, 1, right? What is that called? That's a y-intercept. Okay? Does that make sense to you guys? Okay. All right, so now we've got f being -1. So if f is -1, which domain do we fall in? Why? Because x can equal -1 right there. Why doesn't it fall right here? Because x can't equal -1 there. Good. So for this one, we're going to do -1 squared. What is -1 squared? Just 1. So f of -1 equals 1. Okay. Okay, what about for f of 1? Which chunk do I need to plug it into? Why is it the middle one and not the bottom one? That or equal to part, exactly. So we're going to plug it into the square root of 1 minus 1 squared. What is 1 squared?
1.
What's 1 minus 1?
0.
What's the square root of 0?
0.
So f of 1 equals 0. Okay, so y now equals 0 here, right? Y is equaling 0. What do we call that on a graph? That is an x-intercept. Good. Okay, how about f of -5? What do we plug that one into? The top one. So all we have to do is -5 squared. What is -5 squared?
25.
So f of -5 equals 25. Okay? All right. So, how do we graph piecewise functions then? Well, you have to do it in 3 different parts. So we're going to take the top one first. And we're going to graph x squared when x is less than or equal to negative 2. I think it's a lot easier to just graph the whole thing and then erase the part you don't want. Because if I'm going to have to think through, okay, but I can't do anything like over here, that's too hard for my brain. I can't handle that. I'm just going to graph x squared and then figure out the domain. So what does x squared's graph look like, guys? It is a parabola, and specifically, it'll be a point at 1, 1, but what's 2 squared? What's 3 squared? So it should be going up like that, right? So this is what that parabola would look like. Give or take, right? Let's see. Okay. So that's what it looks like, except for in this case, I only want it when x is less than or equal to negative 2, right? So where is x equal to negative 2? Right here, this point, right? So I'm going to erase everything that's bigger than that, because I don't need it anymore. Does that make sense? Because this part of it does not apply because of the domain. And this does need to be a closed point. Why? Or equal to. Good. Okay. Let's go to our middle section now. Okay. Let's think for a second. What is the graph of 3 minus x? What kind of graph is that? It is a line. I would flip this around. It becomes much more obvious what it is when the x comes first. That is a slope of negative 1 with a y-intercept of 3, right? So again, I'm just going to graph the whole line. There's my y-intercept of 3. If I have a slope of negative 1, it's going to look like this. All the way down through, right? And then we want it specifically when we're between negative 2 and 2, right? So between negative 2 and 2, I'm going to go ahead and actually fill that part in a little bit here. And then we have to decide, should those be open circles on the end or closed circles? They are open. Why? Because it can't equal either of them. Good. Okay, now we have to deal with our last section. And it just says 4. So remember, f of x is a fancy way of saying y, right? So in this chunk, we're talking about y equals 4. What does a line y equals 4 look like? Straight across on 4. Just like that. Yeah? But I only want it when what?
X is
Greater than or equal to 2. So here's where it's 2, and we're going to fill that in because it's or equal to. And then it's this part of it that we actually want. Okay? So I'm going to go back and actually put it in black where this actual graph is. So this one goes here and has a closed circle here. It has an open circle here and is a line until here where it has an open circle. And then up here we've got a closed circle and then it goes this way. That is what that piecewise function looks like. Okay, you guys are not technically allowed a graphing calculator on these tests. You are allowed to use a graphing calculator on your homework while you're trying to make sure you understand. We can absolutely check our work on Desmos. This is kind of a fun one, though. How many of you actually know how to put piecewise function into Desmos? Did you know you can put a piecewise function into Desmos? So x squared, and then it's, ooh, I don't remember how to get to the brackets here. I think it's this. Okay.
Is it supposed to be showing?
Oh, it's not showing, I'm sorry. Yes, it is. Thank you for asking so that I can fix it. So how'd we do? Is that what ours looked like? Yay, we did it. Okay. All right. How do we go the other way? How do we look at the graph and figure out what the heck the piecewise function is? I'm going to be honest, this is a lot harder in my opinion. This is a pretty big skill jump. Okay, first of all, I'm going to think through how many sections of this graph are there? So I need one here, and one here. I need 3 sections, right? I would actually start with writing the domains personally. What's this one's domain? -6 to -3. So -6, -3, x is in the middle. And then I need to figure out our signs. Okay, it has to be in the middle, so they've both got to be less thans, right? But this one should be an or equal to, because the -6 has the closed dot. Yeah? Okay, how about that middle section? What's this one's domain? -3 to 2. And then we have to look and see, do either of them have closed dots? So we need or equal to's on both. And the last chunk, what's the domain on the last chunk? 2 to 6. And do any of them have closed dots? Okay. So we have our domains set up now. Now we got to think through, how do we make a line look like that? So, how do we make a horizontal line? With y equals something. Yeah? Oops. Good job. Okay. What about this one? How do we get a graph to be shaped like that? What kind of graph? Absolute value. Good. Absolute value of what? This one's just x. How do you guys know that? Because it's a slope of 1 on or -1, depending on which side you're on. And it's not shifted left or right or anything, right? It's on 0, 0. Okay. Done. That's what this one is. Okay, what about this last section? What kind of graph is that? It's just a line. It's just a linear graph. So remember, linear graphs are always what? Good. Y equals mx plus b. Okay, here's the thing, though. I have no idea what b is right now. Do you? But you know what I could figure out? If it keeps going, where would it cross? So what's our b? And what's our slope? -1. Good. Ta-da! Okay, these problems do take a lot of steps, but I don't think the steps themselves are that difficult. I think the hard part is remembering that you have to do all of these steps. Yeah? Okay. We sort of talked about this already, but let's go ahead and flip back to our definitions. Okay, so we need to know what the values of a function f that are the solutions to the equation f of x equals 0. They are also known as roots and x-intercepts. Does anybody know what word I'm looking for? Zeros. And I never know which way I should spell zeros. It bothers me both ways. I don't know, I'll go with that one.
There's 2 ways to spell.
Yes, there is.
What's the other way?
With an E before the S at the end. It's a British versus American thing, but either way it bugs me. I guess we'll go with this way.
Okay. Yeah, this one has less letters.
Yeah. Yeah. It doesn't actually matter. As long as you know that it's supposed to say zeros, we're going to be okay. This is not English class.
That's right.
Okay. So, the next chunk of this section that we need to talk about has to do with this right here. We need to be able to determine whether a function is even, odd, or neither. Do you guys at least remember learning about even, odd, and neither? Okay, good. Does anybody remember what the definitions are? Yeah, that sounds right. What if I show you this? Does that help? Okay, so let's read the definition. The graph is supposed to be symmetric about the y-axis. So think about what kind of graph would be symmetric about the y-axis. A parabola would be a great example. What's the degree of a parabola? 2. Is 2 even or odd? Even. So which one do you think this one is? Ta-da! Yes, degree is just the highest exponent. I'm sorry. Okay. The next one is think about a graph that is symmetric about the origin. What's a graph that's symmetric about the origin but not the y-axis? How about x cubed? Is 3 even or odd? Everything I do with even and odd, I associate with either x squared or x to the third. All of them. Okay? Because this would be from x squared. 2 is even. This is x to the third. And 3 is odd. Okay? So how would a function be neither even or odd? If it's not symmetric about either either the y-axis or the origin. It actually happens a lot. For example, is this function even or odd or neither? Neither. None of the above, right? How about this one? Neither. There are other examples that aren't piecewise functions, but that's a good example for you. Okay? All right. So, here's the other thing about even, odd, and neither. They also hold these algebraic properties. Okay? So the graphing is great if you have a graph. What if you don't know what the graph is supposed to look like, though? You still need to be able to say if it's even, odd, or neither. That's where these algebra properties come in. Okay? In an even function, f of negative x should be equal to f of x. Let's think about why. If I was doing x squared, and I had my x's and my y's, if x is negative 2 squared, that would be 4, right? Negative 1 would be 1, 0 would be 0, 1 would be 1, 2 would be 4. But think about this. This is f of negative 2, and what does it equal?
4.
But this is f of 2, and what does it equal?
4.
So they're the same. That's what it means. That's why it's symmetrical. Okay? So with odd functions, it's kind of a similar thing, but it's a lot harder to see. So this one would be like negative 2, 8. Or sorry, negative 2, negative 8 would be that point. And this point would be 2, positive 8. So what we're saying is if we took f of negative 2, that equals 8. But what if we took negative f of positive 2? What is f of 2? So they both come out as negative 8. Yeah? Is that the lunch bell or the go bell? Excellent. I panicked for a second there. Okay. Does that make sense to you guys, like why these properties hold then? It's because of that symmetry. Okay, so I'm going to clean this back up a little bit so it's not quite so crazy when I save the notes. Okay. So, now that we've talked about it a little bit, we need to decide if they're symmetric about the x-axis, y-axis, origin, or none. How about this one? Is this symmetric about the y-axis? No. Is it symmetric about the x-axis? Is it symmetric about the origin? Yes. Okay. So what kind of function would that be? That's odd. It doesn't ask, but we're going to put it on anyway. Okay, how about B? So remember, the origin is clear over here. It's not even on this graph. Is this symmetric about the y-axis? Is it symmetric about the x-axis? Is it symmetric about the origin? No. That's another good example. Lines can be even or odd. Most of the time lines are neither. The only time they're going to be, well, I guess they can't really be, well, horizontal lines can be even. In fact, they are even. Vertical lines are neither. Lines that have some kind of slope are only odd if they go through the origin. Lines are weird. That's why we don't really talk about even, odd, or neither until we're talking about more than just lines, because lines are weird. Okay, how about this one? All of the above. So they are even. Well, I guess let's do this. Okay, so they're symmetric about the x-axis. They're symmetric about the y-axis. And it's symmetric about the origin. So is it even, odd, or neither? So it's both even and odd? That's possible? Yes and no. Is it a function? What's the definition of even? Even and odd specifically apply to functions. Is a circle a function? No. It is still symmetrical about both of those things, but calling it even and odd is kind of misleading. Does that make sense? Okay. All right, how about this one? Is it symmetric about the y-axis? Is it symmetric about the x-axis? Yes. Is it symmetric about the origin? Okay, is it a function? No. So is it even or odd? Neither. Because it's not a function. Okay. How do we determine if a function is even, odd, or neither if we're given the equation? Highest degree. What's the highest degree of this one?
Well, 6.
6. Therefore, it's even. Okay? Oh boy, what do we do with this thing? Is it? I don't know. Let's ask Desmos. Come on, little guy. Okay, so this is what that graph looks like. Makes me uncomfortable too, don't worry, guys. It's gross, I know, I'm aware. Okay, well, that's what it looks like, though. So, it is symmetric about the origin, which makes it... What's up?
How can we know that without making the graph?
Personally, I would use your algebraic rules. Okay? So, for example, if it's even, then f of negative x would equal f of x, right? Am I writing that right? Pause. Let me make sure before I lie to you. Okay, we're good. Whew. Okay? So what that means is if you plug the negative in and it comes out the same, then it's going to be even. So, f of negative x would equal the absolute value of 2 times by negative x divided by a negative x. So if we simplify it a little bit, that would be the absolute value of negative 2 over x divided by negative x. What would happen here? If you take the absolute value of a negative, what are you going to get back out? No matter what, that's going to be the same as the absolute value of regular 2x, right?
Yeah.
But then we're dividing by a negative x. Does this match this? So is it even?
No.
So it's not even. So let's check and see. Is it odd? So in order for it to be odd, we need f of negative x, which is this guy, or this guy, to equal negative of f of x. So if we put a negative in the front, is it the same? So that would be negative absolute value of 2x over x. Are these two equivalent?
Yes.
Why?
It's because when you divide by a negative, the whole thing becomes negative, so that must be the same as this other equation.
Exactly. So remember with fractions, what's the difference between what are the difference between these three fractions?
What is starting?
As far as equivalency goes, you're gonna get the same thing no matter how you do this. These are all actually the same. So what does that mean about the negative? Well, it means it can be out in front, that's fine. It means it can be in the top, that's fine. It means it could be in the bottom, that's fine. What it can't be is in both. That's a problem. But these are all the same thing. So if it's in the bottom or if it's out in front, does it matter? It's all the same. Does that make sense to you guys? Yes.
Couldn't you also say that because one is technically the highest degree and that's an odd number, that it would be odd? Or
Sure.
does that work every time?
What's the degree of an absolute value function, though?
It's technically wouldn't it?
Just kind of doesn't apply to absolute value functions. I guess technically it's 1, but that's misleading. Because think about even functions. X squared, they both go up, right? X to the 4th, what happens? X to the 6th, X to the 8th, they all go up, right? But in an absolute value, they also both go up, right?
Yeah, so then this one would be count because it has an x that's not in the absolute value, so then that makes it odd.
Yes, give or take. Okay. How about this one? Is this one even, odd, or neither? This is why I say the power doesn't always work perfectly. Because this one's x to the 1/2. Is 1/2 even or odd? It doesn't apply. It doesn't apply to fractions, right? Okay, so what can we do instead? Well, the first thing you're going to want to do is find f of negative x. Oops. Okay. How do we simplify this? What happens when you try to do minus a negative?
Becomes 1 half.
Okay, so do f of x and f of negative x match? Are they the same? Are they equal? No. That tells us that it's not even. Because f of negative x does not equal f of x. Okay? So then we got to try negative f of x. So that means we take the whole thing, we put a negative in front of it. So does that match that? Are those the same?
Yeah. It depends.
Think about it this way. Let's pretend we had the square root of 9 and the negative square root of 9. What's the square root of 9?
3.
What's the negative square root of 9?
3. Negative 3. Oh.
Because it's 3 and then you have to apply the negative. Are these the same thing? No, they're opposites. So is this one odd? So it's neither. Questions, comments, concerns on that one? Go for it.
So looking at the square root of 9 and square root of 8,
Yep.
can't you like, because also is it negative 3 times negative 3 is 9, and so the square root of 9 will be that, so
Sure. Because this is all I said before was that it was 3 and negative 3, right?
yeah.
So I want you to think through this. This could be plus or minus 3. That's true. But that means that this one is then the negative plus or minus 3. So if it's negative plus 3, how do we simplify that? But if it's minus a negative 3, how do we simplify that?
Aren't they the same thing?
No. Order of operations. Let me think through this. How do I explain this better? Okay, if we rewrote this as 9 to the 1/2 power, you guys agree that that's the same thing? You can write roots as fraction exponents, yes? Which gets applied first? The 1/2 or the negative? The 1/2. So this negative is always just going to get tacked on to whatever your answer was in the first place. So this part and this part are always going to match. That's true. But then this negative is going to be on the end of it. Does that make more sense? Okay. It's order of operations is the reason, because you can't multiply by -1 until the end. Okay. Let's try this one out. What do we need to find first?
F negative x.
Good. Always start with f of negative x. That means that we plug negative x in anywhere we see x. Okay. Well, what is 3 times negative x?
Negative 3x.
Okay, what's negative x squared?
X.
Good, because that's really just negative x times negative x. Negative times a negative makes a positive. X and x make x squared. Yeah? We okay with that? And then it's supposed to be plus 1 on the end, right? Okay, so again, does f of negative x equal f of x? Is this the same as this? No. So it's not even. We okay with that one?
Yes.
Okay, and then we need the negative f of x. So that means we would just stick a negative out in front of 3x over x squared plus 1. So, is f of negative x equal to negative f of x? So, yeah, so the negative out in front or the negative inside. Is this the same as this?
Yes.
Yes. So this one is odd. How do we feel about those ones? I know they're tricky, but are we okay, we think? Yeah.
Since the negative 3x over x squared plus 1, that was the even one, and that was incorrect. But then the odd one.
Okay, so it goes back to the definition. The definition of even says that f of negative x would equal f of x. Those would match. So that would mean that this one and this one have to match because this is f of x and this is f of negative x, right? But the definition of odd is that f of negative x, which is this one, would have to equal the negative of the f of x, which would be this one. So do these two match? That's why this one's odd. Does that help?
Yes.
Okay. Any other questions on these before we move on? I know they're a little bit tricky, but I promise the more you practice them, just the better you get at them. I promise. Okay. Increasing, decreasing. I think we know this, yes. If we go back to our definitions really quick. Okay. I think you guys are familiar with increasing and decreasing on graphs. I think you guys could do that in your sleep, honestly. But they do have formal definitions that are very handy when you get to calculus. So I want to make sure you guys have at least seen them. Okay? So this is saying if A is less than B and f of A is less than f of B, that means as you're going to the right, because B is bigger than A, right? Is y getting bigger also? So if both x and y are getting bigger, it's increasing. Okay? Whereas if x is increasing, because x is always increasing in these definitions, this means that y is decreasing though. Does that make sense to you guys, what those are saying? Because remember, this is y. F of something is a y. So this is saying, this part is saying as x gets bigger, and this part is saying y is also getting bigger. Okay? This part still means as x is getting bigger, because that's what we said the first time. And this part means y is decreasing. Okay. And then for this one, this actually means the same thing still. It's saying as x gets bigger. And this part is saying y stays the same. Okay? You guys know those definitions. You just haven't seen them in more formal math notation. It still means what it's always meant. Okay? So, estimate for me. Where is this increasing? In the middle here. So I don't know, somewhere like here to here-ish is where it's increasing. Let's go with -1.5. I don't know, guys. I told you to estimate. Until +2. That seems right. Yeah? We okay with that one? Okay. Where is it decreasing? The rest of the graph. So -infinity up until -1.5-ish. And also from 2 to infinity. Okay, something my freshmen always struggle with decreasing is why are these parentheses if there's not an open circle there? Do you guys know why? It's because at a point, it's neither increasing or decreasing. It just is what it is. It's not changing at a single point, right? At one single point, it's like the picture instead of the video, right? I don't know what's happening. All I can see is the picture. We're only looking at the one point. I hope that helps. Okay, how about for B? When is it increasing? So this chunk. What else? And this chunk. So sure, -infinity up until 1. And then also from 4 to infinity-ish. Okay? So where is it decreasing?
1 to 3, 3 to 4.
So why is 3 showing up in both places there? Because it's an asymptote. Question of the day, is that an even or an odd asymptote? Do you guys know? That is an odd asymptote. Why? Because one of them goes down and one of them goes up. Good. You don't actually have to know that yet, but I always like to know if you remember it. Good. Okay. When it says find the extrema, it means this. It means find your max, find your min, find your local maxes, and find your local mins. So let's go back to some definitions. Okay, technically this should actually say extremes. So extrema is the plural. Okay? Extreme is the singular, extrema is the plural. So the reason it should say extremes is because of grammar. So extremes are just any point at which the value of a function is the largest or the smallest. There are both absolute and relative. Relative and local mean the exact same thing. Okay? So a local or relative maximum or minimum is a higher low point within some neighborhood of f. We'll talk about that in a second. And then the absolute or global maximum or minimum is the higher low point for everything. Yes. Yeah. What time do we get out today?
106.
Okay, thank you. Okay, so I didn't write it because I never write it. These are technically the absolute max and absolute min. I just never ever write it. Yes, Suzanne?
Can a graph have multiple maximums?
Yes. It can only have one absolute max and it can only have one absolute minimum, but it can have infinite relative maxes and relative mins. Okay? So these ones, there is only one possible answer. These ones, there are infinite possible answers. Yes.
I mean, like in the sense of like a sine or cosine wave.
So sine and cosine actually don't have absolute maximums or minimums because it happens more than once. So like the crest of the top of the sine wave, like we think of that as like the maximum, right? But it's actually a relative maximum, not an absolute one, because it happens over and over again.
Do
Sometimes, not always.
If the maximum on a piecewise function is part of a cosine or sine wave, is it the maximum then?
Yes, because the domain is restricted.
Okay.
Yes. No, those are great questions. Okay, so the absolute max is just the highest overall point. What's the highest overall point here? It's right here. You're going to want to write it as a pair, like an ordered pair, most of the time. Okay? So what would be its absolute minimum here? Okay, this one's a little bit weird, I'm going to be honest with you. Because is that point actually included on the graph? But it's still its minimum. But it's not included on its graph. It's weird. I know. It is still its minimum. Okay? Because how do you say, like, as close to this point as you can possibly get, but not the actual point? Like, that decimal would go on forever, right? It would be 0.9 repeating. So, like, you can't really write that. Like, I can't say negative 4.9 repeating. Negative 4.9 repeat. Like, that's not, we're not going to mess with that. We're just going to call it that point. Okay? All right, so what about a local maximum? Are there any local maximum? I would say this is a local maximum. It's higher than anything else around it. It's just not the highest point. So when I say neighborhood of F, I mean, like, I don't know, look kind of close to it.
So
It's relative. There's not a definition of neighborhood. I don't know, kind of close to it. At least not a mathematical definition of neighborhood. So the local max would be there at 2, 3. What about a local minimum? Good.
So then, could 1, 3 also kind of be a local minimum? Or, I mean, 3, 1, not bad.
This one? Maybe. Depends on why you're looking at it and why you need it. I wouldn't ever mark it wrong for not having one. Because, like, we don't really know what it does over here. What if, in theory, it keeps going down? We don't know. Does that make sense? Okay. All right, find the intercepts. What's the y-intercept? 0, negative 1, good. What are the x-intercepts?
Negative 1, 0.
Good, negative 1, 0 is one of them. What else? All of those. Remember, there's only ever going to be one y-intercept, but there can be infinite numbers of x-intercepts. As long as it's a function. Yep. Okay. So now help me find f of 2. Remember, 2 is what kind of value? That's an x value. So let's go to x equals 2. What does y equal when x equals 2?
Wait, am I looking at 5 things?
No.
Oh, yeah, I'm not.
Okay, and then it wants to know when f of x equals negative 5. So what kind of value is negative 5 then? That's a y value. So let's look at our y value. When, for what x is y negative 5?
But it's not a point of the graph.
It doesn't exist. There is no x value for which y equals negative 5. It's undefined. It's an open circle. Yeah.
Just going back to the extreme, I
Mhm.
couldn't use a bracket or an extreme on the board and signify that it is a solid dot.
No. It's very good logic, but conventionally we just don't do it. Ordered pairs are always parentheses because they're not interval notation. Does that make sense? Okay. Okay. We are going to stop there, but you do have homework tonight. It's this. I want you to fill in what each of these parent functions look like before next time. Okay? And if you're not sure about one, Google it. If you are registered for the class already, I highly recommend you do the 1.1 and 1.2 practices. If you're not in the class yet, stay tuned for an announcement that I hopefully get you sometime soon to tell you what to do.
Is it all on Canvas?
It is all on Slick Canvas. Thank you for reminding me. It's all on Slick Canvas, so you'll need to log into the SLCC Canvas. Go to slcc.edu and click on My SLCC and then Canvas.
Because I checked it and it's like all of the classes are there in like the courses, but none of them are active for me. Or should I just check
Maybe
it
you
out?
forgot to publish it.
Okay.
Give me 5 minutes.
Okay.
Melena, you know me. You know I probably just forgot to push publish.
Thank you.
You're welcome. Have a good day, Jack.
4, 5 including biology lab. I have 4 college classes, technically 6 because Eli's been here.
There you go, Melena.
Good.